This is lesson 4.4, where it's concerning proofs with perpendicular lines. And so we won't be doing any formal proofs, but what we're trying to do, or what our main objective is understanding and using theorems to show that lines are perpendicular. So when giving a figure or giving some sort of image, do we know the correct theorems or ideas that help us show that these lines are perpendicular, or if these lines are also parallel? We'll kind of combine it with the last lesson as well, using knowledge of parallel lines or perpendicular lines to show if there are other parallel or perpendicular lines. So just as a brief review, remember, perpendicular lines are two lines that intersect at a right angle or a 90-degree angle. So the angles here are all 90 degrees. And then parallel lines are the two lines that don't cross. Okay? They have no intersection point, but they're in the same plane. Okay? So we have perpendicular lines and parallel lines. So there are a few theorems in this lesson that we'll want to know. The first is the linear pair perpendicular theorem. That says if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. And you can see here written out in symbols as well. If angle 1 is congruent to angle 2, then G is perpendicular to H. Okay, so if we look in our figure here, we have line G intersecting line H, and they form a linear pair. Okay, those two angles that have a common ray here in the middle. And we see that angle 1 is congruent to angle 2. Okay. Well, if you have two lines intersecting form a linear pair, and the two angles that are in that linear pair are congruent, then they must be the same. Because remember, a linear pair, the angles are supplementary, they add up to 180, and if they're both going to be the same angle, or the same measurement, then they are both going to have to be 90 degrees, which means that these two lines are perpendicular to each other. Okay. So if, when they form a linear pair of congruent angles, then the lines are perpendicular. The next theorem, the perpendicular transversal theorem, says that in a plane, so in the same space of a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line as well. So again, in this figure, if H is parallel to K and J is perpendicular to H, then we know J is perpendicular to K. So looking in this figure, what we're given is that H and K are parallel to each other. Remember, these little red arrows here are indicating that these two lines are parallel to each other. So we know that H is parallel to K, and this transversal J is perpendicular to H. And this is perpendicular to H. And so what this theorem says, that if we know that J is perpendicular to H, then J is also perpendicular to K. So there's a right angle here. And it's perpendicular to both of them. If it's perpendicular to one parallel line, it's perpendicular to the other parallel line. The last theorem states that lines are perpendicular to a transversal, or concerns lines that are perpendicular to a transversal. So in a plane, okay, if two lines are perpendicular to the same line, then they are parallel to each other. So this is a little bit of the reverse of what we were just looking at. So this says that if M is perpendicular to P and N is perpendicular to P, then M and N are parallel to each other. So this is just saying that if two lines are perpendicular to the same line, then those two lines are going to be parallel to each other. Okay? So the last one was saying that if two parallel lines if one line is perpendicular to two parallel lines, then it's perpendicular to both. This one's saying if two lines are perpendicular to the same line, then those two lines are parallel to each other. So you don't necessarily need to memorize all of these theorems, but you need to know where you can access them in your notes to use them, because that's the main objective, is to understand them and then to know when and how to use them. So let's look at a couple of examples that are in your notes. All right, so this is example, I believe, 4. Yeah, this is example 4 in your notes. And in your note page, it's probably hard to see because it's pretty dark. It didn't print very well. And so it's probably better to look it up here on the video. And so we have this image here of these streets in this city. And we have line A, line B, line C, and line D. And then we're giving a little bit of information about them. We're told that A is perpendicular to C here, A is also perpendicular to D, and B is perpendicular to D. And the question is B parallel to A? So we don't know for sure if B and A are parallel to A. If B and A are parallel to each other, there's nothing in our figure that's indicating that. And so we want to see, is that true based on the other information that we have? And we'll explain our reasoning. So let's look at the reason for this. So the question is B parallel to A? Is line B parallel to line A? And so to go about proving that, we'll need to use our theorems. So the ultimate answer is yes, B is parallel to A, but why is that? We need to be able to explain our thinking. That's the main piece there. So we need to look at, what do we know? Hey, we know that A is parallel to D, and B is also parallel to D. Well, we learned a theorem, the lines perpendicular to a transversal theorem, that says if two lines are perpendicular to the same line, then those two lines are parallel to each other. Okay? So since A is perpendicular to D and B is perpendicular to D, A and B are parallel to each other. That's what the lines perpendicular to a transversal theorem says. When you're trying to decide, okay, what theorem am I going to use, you need to look at, okay, what information do I have? Because the lines perpendicular to a transversal theorem talks about two lines being perpendicular to a transversal, that's indicating to me that I'm going to use that theorem, because that's what I have here. I have two lines perpendicular to the same line D. And so you may not know that off the top of your head that, oh, these two lines are perpendicular to the same line, so they must be, they're going to be parallel. But you can, from this figure, identify this one's A is perpendicular to D, B is perpendicular to D. So if I look through my theorems, the theorem says that they'll be parallel to each other. So yes, B and A are parallel to each other. Let's look at one more example. So this one says, is B perpendicular to C? Explain your reasoning. So is line B here perpendicular to C? And that's what we're trying to prove. We know that these other lines are perpendicular to each other, but is B perpendicular to C? We can't just say that it's like, oh, all the other ones are perpendicular, so yeah, that one probably is too. It's like, no, we need to actually explain if it's true or not. So let's look at the answer. All right, so ultimately, yes, B is going to be perpendicular to C, but why is that? Okay. Look at what we know. We know B is perpendicular to D, okay, this line down here. Okay, this little symbol means perpendicular, or not, it's a right angle, so that means this B line is perpendicular to line D. And we know the lines perpendicular transversal theorem says that C is parallel to D, because they're both perpendicular to A. So since C is perpendicular to A and D is perpendicular to A, okay, the lines perpendicular transversal theorem says that C is parallel to D. Okay. So now we know that C and D are parallel to each other. Well, if C and D are parallel to each other and B is perpendicular to D, then the perpendicular transversal theorem says that B will be perpendicular to C. Okay? The perpendicular transversal theorem says that if a line is perpendicular to one of the parallel lines, it's also perpendicular to the other parallel line. So if we recap there, since C and D are both perpendicular to A, that means C and D are parallel to each other. That's the lines perpendicular to a transversal theorem. And then since B is perpendicular to D, and we now know that D and C are parallel to each other, the perpendicular transversal theorem says that B is also going to be perpendicular to C, because if it's perpendicular to one of the parallel lines, it's perpendicular to the other. Okay, so that's the reasoning that we're trying to use. We say, yes, B is going to be perpendicular to C, but why is that? We're using our theorems to support our reasoning. That's our evidence to show that this is accurate. So again, you're not going to necessarily memorize all those theorems perfectly, but you need to be able to identify, it's like, okay, I know I'm talking about perpendicular lines here, I'm talking about parallel lines, I'm looking at multiple perpendicular lines or multiple parallel lines. Which theorem kind of works with that, and what's that helping me do? right? Because each theorem is helping you kind of accomplish a different task. So you'll want to make sure you know how to use those and you understand what they're saying. Okay? So that is what this lesson has been over, is providing reasoning for showing if lines are going to be perpendicular to each other or if they're going to be parallel to each other based off of the perpendicular lines.